Hi there. This video is going to show you a basic introduction to recursion and how recursion actually works. I'm making this video because recursion is a very difficult topic to understand when you first see it. And I've been using recursion for a little while now to help solve problems, so I think I have a decent understanding of how it works, but I find students are always confused when they first see it. So the first thing to note is that to understand recursion, you really have to have a solid understanding of methods, parameters, and how those work with the flow of control of the program. So if you're still not really sure about how methods work, I'd recommend doing some review of that topic before you try and understand recursion. And I also think that it's important to understand how recursion works with the computer and memory before you try and use it to solve problems. So what I have here is a really simple example, and I'm using this Java visualizer that the University of Waterloo created, which is a really excellent tool to peek behind the code into memory and see what's actually going on. And I just want to point out right now that at the bottom here, the University of Waterloo has created a whole bunch of examples that you can take a look at, like control flow, and pass by value, recursion, lots of great examples that you can look at. You don't even have to code them, you just load them up and then you can visualize and look at how the program runs. But let's take a look at this example here that I have. I have a main method and another method called countdown. Countdown has one formal parameter, int n, and inside the method, all we're doing is printing n out. In main, I'm invoking the countdown method with an actual parameter of 4. So let's take a look at how this works when we run it. So the flow of control starts in main, and the first thing that happens in main is that countdown at 4 will be invoked. So over here on the right, we can see under the frames that a new method call has been added. The method is called countdown, and there's a local variable called n that has the value 4 stored in it. So inside the countdown method, the first thing that happens is that the system.out.println runs, so 4 gets printed out. That's the last thing in the method, and the method's done. It returns void. The return value is void, and the flow of control jumps back to main, and that's the last statement in main, so the program is finished. This isn't a recursive program. Let's make it one. So a recursive program is a recursive method is one that invokes itself. So inside the method body, we're going to invoke the countdown method with n-1. So let's take a look at what happens here. So right away we can see that there's a problem. It's telling us that we've exceeded the max visualizer stack size. So let's take a look at what that means and why it happens. So again, we start in main, we invoke a countdown with 4. There is our countdown method with an n of 4. So inside the method, n gets printed out. So there's our 4. And then the next thing that happens is that the countdown method is invoked with an n of 3. So now take a look at this. This is the stack. Each time a method is invoked in your program, it gets added to the top of the stack. It's not removed until the method returns. So n of 4 is waiting down here for n of 3 to finish. But n of 3, what it's going to do is it's going to print out 3, and then it's going to invoke countdown with 2. So we can see another method gets added to the top of the stack. What happens with n of 2? Well, it prints 2, and then it invokes countdown with 1. So now we have 4 countdown methods on the stack. And unfortunately, because this is not a very well-designed recursive method, our countdown methods are going to continue to be added to the stack infinitely. Well, not really infinitely, because we're dealing with a computer and memory is limited. So the stack size is a limited size, and eventually we get too many of these countdown methods and the stack overflows. So here it's telling us we've exceeded the stack size, the largest possible stack size. If you were to run this in regular Java IDE like NetBeans or Eclipse, you're going to get a stack overflow exception. So how do we avoid this exception? Well, we need to add something to our recursive method called a base case. So every recursive method should have a base case, and this is what a base case is going to look like. It's going to say if n is less than or equal to 0, then what we'll do is we'll just return. Else, meaning n is greater than 0, what we'll do is print n and then recurse. So this is our base case. There's no recursive call here. Eventually, what we need to make sure is in our recursive methods is that they are trending towards the base case. They're going to reach the base case eventually. And we can see that will be the case here. So let's take a look at what happens when we visualize it now. So countdown at 4 gets invoked. We can see that there's no red errors here, so we should be on the right track. So the first thing that happens is that the base case is checked. Have we reached the base case of our recursive call yet? No. N is not less than or equal to 0. So we go ahead and run the body of the recursive method. We're going to print out 4, and then we're going to call countdown of 3. So countdown of 3 gets added. The base case is tested. It passes the base case. Or I guess technically it fails this test. This test is false, so the else clause executes. N of 3 gets added to the stack. And then n of 2. N of 2 won't activate the base case. So 2 gets printed out. N of 1 won't activate the base case. So n of 1 gets printed out. And countdown of 0 is called. Countdown of 0 does invoke the base case because 0 less than or equal to 0 is true. So here the return statement activates. And so this n of 0 countdown method does not recurse. The recursion stops. And now our methods start to be removed from the stack. So n of 0 returns void. And now we're back in countdown with an n of 1. It also returns void because we're down here after the else and the if. There's nothing left to do in that method, so it returns. Same with n of 3, same with n of 4, and then we're back to main. All of the method calls have been removed from the stack, and our program is finished. So there you have it. There's a basic example of how recursion works with the stack and a simple recursive method. If you're new to recursion, there's a few more classic examples that you can check out. One is factorial. So factorial is a method that the mathematical definition of a factorial is actually recursive. Another good example to check out is the Fibonacci sequence. So that is another one where the mathematical definition of the Fibonacci sequence is itself recursive. So I'd recommend looking up those problems, using the Java visualizer to take a look at how the method calls get added to the stack and how they get removed from the stack. Once you have an understanding of how recursion works, then you can use it to try and solve problems. However, just the caveat, it is really confusing to understand recursion and to use it properly. So if you still don't get it, don't be stressed. Just keep working at it. You'll get it eventually. Thanks for listening.